Please pause the video and try this proof. So this is what we should have had. Notice that there were 6 steps in order to prove that angle M was congruent to angle N. So I had my 2 givens. Notice that the second given was a vocab word, median. So that meant that I needed to expand on it. So I was able to state that MT and NT were congruent, because if a segment's a median, then it's going to divide a segment into 2 congruent segments. Those 2 triangles shared a side, so AT was congruent to itself by the reflexive property. That got me 3 sets of sides congruent in those 2 triangles. So I have 2 congruent triangles by side, 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 and then CP, corresponding parts of congruent triangles are congruent. That allowed us then to get that angle M and N were congruent. So my question then is, what type of triangle is this triangle AMN, and how do we know? Okay, that's what we're going to be talking about today. Well, we've already talked about triangles in section 3.6, the different types of triangles. So hopefully we're thinking that, okay, in the big triangle AMN, AM and AN were congruent. So you have a triangle with at least 2 sides congruent. Remember, that means that it's an isosceles triangle. So in this problem, even though I didn't state it, we had an isosceles triangle. All right, so that's going to take us to the section that we're looking at today, which is section 3.7. We're going to apply theorems relating the angle measures and the side lengths of triangles. So let's talk about a couple of theorems here. So we have a couple of if-then statements. So the first statement says, if 2 sides of a triangle are congruent, then the angles opposite those sides are congruent. So that if-then sentence is actually something that you're not going to have to write out fully when we're doing proofs, because I have a notation that is going to shorten it up. So if it says if 2 sides of a triangle are congruent, so we're going to be able to designate the if part by saying if, and then I'm going to draw a triangle, and I'm going to mark 2 sides congruent. So this represents that if 2 sides of a triangle are congruent, then, and now I get to state that the angles opposite those sides are congruent. So I'm going to draw another big triangle. Because I had the 2 sides up at the top, we'll notice that the angles directly across from them are these bottom angles here. And if we remember back to when we were talking about isosceles triangles in section 3.6, remember we have the 2 legs congruent. That third side is the base, and so base angles were congruent in a triangle. Okay, my second theorem states if 2 angles of a triangle are congruent, then the sides opposite those angles are congruent. So essentially, it is just that first theorem, but it's flipped around. So our notation, instead of writing that whole if-then, we can write if the angles are congruent, then the 2 sides opposite them are congruent. So we're essentially just flipping the 2 triangle pictures around. So that's why, because they're so close and similar to each other, it's going to be important to know what was I given versus what am I concluding, to know, am I starting with the 2 legs and then proving the angles, or am I starting with the 2 angles and proving the legs? So let's take a look at this algebra problem. It wants us to find the measure of angle B. Notice that angle B is given to us as x. So we're going to have to figure out what x is. The issue is I have one angle is 38 and then an x. If we remember, we know that 3 angles of a triangle are going to add to 180. But right now, I'm only giving us what 2 of those angles are. But if we look at the triangle ABC, because I have 2 sides marked, we can think about the theorem that if the sides are congruent, then the angles that are directly opposite them are congruent. So that means that angle C and angle B are actually congruent. So if angle B is represented as x, well, then so is angle C. So I can set up an equation where now I know what each three of those angles represent. I can add them up to 180. So 38 plus x equals 180. So I can combine like terms. X plus x is 2x. I'm going to subtract the 38 over to the other side. So 180 minus 38, we now know that 2x is going to equal 142. And then I'll divide both sides by 2. And so that gives me x, which is angle B, to be a 71-degree angle. So there's my answer. All right, I would suggest that you sketch this picture. Everything's marked up. We're going to be finding two different segments and the measure of an angle. So in part A, it wants us to find the length of BD. Okay, so notice that I'm going to first start with the fact that BD is a part of two triangles, but there's a lot more information kind of going on in the triangle over here of ABD. So I'm going to focus on this triangle first. Notice that I have this triangle where I'm giving one side to be 60, one side to be 64, and I've got two angles in that triangle that are both 58. And so because both of those angles are 58 degrees, that means that since those two angles are congruent, then the sides directly across from them are congruent. So notice that the side that's across from angle A is marked with one tick mark. So that means the side that's across from angle BDA, that also gets one tick mark. And so because that means that the segment BA and BD are congruent, and I know that BA is 60, that means that BD is also a length of 60. All right, so now I know that this is 60. If we look then to find the length of CD, we'll notice that CD has one tick mark. Now that I know that BD is 60, those two are congruent, so that means that that is also 60. Notice that a length doesn't have a degree symbol either, okay? You don't measure segments with degrees. You measure it with centimeters or inches or whatever the unit is, so no degree symbol there. But if I want to find the measure of angle C, that is going to be in degrees. So if I look at angle C, it's a part of several different triangles, but the triangle that I say we should focus on is this triangle that I'm highlighting in green, the triangle DBC. Because in that triangle, we know that BD and DC are congruent because of the markings. And so because those are congruent, that means the angles that are directly opposite them are congruent. Well, the angle that's across from the side CD, that's 29 degrees. The angle that's across from BD is the angle that we want. These two angles are congruent. So if that angle of CBD is 29 degrees, so is angle C. All right, let's take a look at this. We are given that the triangle SUN has the three angles where angle S is represented as 5x minus 2, angle U is 2x, and angle N is x plus 30. After we find for x, we're going to determine if we have a scalene, isosceles, or equilateral triangle. All right, so even though we're given angles, we're going to be able to use the relationship of the angle measures to relate to the sides. But we're going to start with the fact that because I'm giving you three expressions for angles, three angles of a triangle add up to 180. So I'm going to take 5x minus 2 plus 2x plus x plus 30 and set that equal to 180. 5x plus 2x plus 1x is going to give us 8x. I've got negative 2 plus 30, so that gives me a positive 28. This still equals 180. So to start getting x by itself, I'm going to subtract 28. So 180 minus 28 tells us that 8x now is going to equal 152. I'm going to divide both sides by 8, and I'm going to get x to be 19. I'm going to plug that value into each of the angles. So I'm going to find the measure of angle S, the measure of angle U, and the measure of angle N. So we're going to have 5 times 19 minus 2. We'll have 2 times 19, and we're going to have 19 plus 30. So let's figure these angles out. Well, 5 times 19 is 95. When I subtract 2, I find out that that angle is 93 degrees. 2 times 19 is going to give us angle U to be a 38-degree angle. And then 19 plus 30 is going to give us 49 degrees for that angle. Okay, so once again, I'm giving us angles. I need to figure out what kind of triangle it is based off of the sides. So remember, if I have an isosceles triangle, I know that 2 sides are congruent and 2 angles are congruent. Well, in this picture, there are no angles congruent, so it can't be isosceles. We talked about equilateral triangles where all the sides are the same. Well, in an equilateral triangle, all of the angles are the same as well. I don't have all of the same angle measures. So that means that because every single angle is a different size, that means every single side is going to be a different length, because that's how the sides and the angles relate. However many congruent angles you have, that's how many congruent sides you're going to have as well. With no congruent angles, that means that I have no congruent sides. So this is a scalene triangle. So once again, I'm going to write down that written explanation. So with no angles congruent, we will have no sides congruent. That's how the relationship between angles and sides of a triangle work. All right, let's take a look at this. We're going to solve for x, and we're going to find the measure of angle S. So notice that I'm giving us angle M is a y, angle N is x plus 30, and angle P is 2x. So there's 2 different variables. There's x's and there's y's. Let's think about this. We might have to set up a system, but I'm going to look at the picture first and see if we can do anything and get around not having to set up a system. So the fact is that we have 2 sides marked congruent in this picture. We have side MN and MP. So because those 2 sides are congruent, that means the angles directly across from them are congruent. Well, the 2 angles across are angle N and angle P. So this angle is congruent to this angle. Both of those have an x. So if they're congruent, I get to set them equal. So I don't even have to worry about the y as of right now. I can solve for x very easily. So I'm just going to subtract the x over to the other side, and that tells us that x is 30. So that was one of my answers. Now they want us to solve for angle S. There is no angle S. They probably mean angle M. Okay, so if I want to find the measure of angle M, which is a y, I don't have that. So right now, what I'm going to do is I'm going to substitute x into both of those expressions for the x's, and I'm going to figure out what angle M and angle N and angle P are. So the measure of angle N is going to be 30 plus 30. So that's a 60-degree angle. Notice that then is going to be the same exact as angle P. Regardless if I substituted 30 in or not, notice that 2 times 30 also gets me 60 degrees. So to find the measure of angle M, I know that 3 angles of a triangle add up to 180. So 180 minus 60, that's going to get me what I'm looking for. And so when I subtract, we actually get another 60-degree angle. So in this, because all of the angles are congruent, not only is this an isosceles triangle, but technically that means that NP gets to be marked the same. This is an equilateral triangle. All right, let's take a look at this. So in this picture, I have a triangle where angle B and angle C are congruent. That means that the sides directly across from them are congruent as well. So that means that AB, which is across from angle C, is going to be congruent to AC, which is across from angle B. I'm going to start marking up my picture. I know that AB is 2x plus 2. I know that AC is 5y. Angle B is 10x. And angle C is 12y plus 16. We're going to find both x and y. So notice that the pieces that I have congruent, which are the two different angles and then the two different sides, they each have an expression where one of them is an x and one of them is a y. So we are going to have to set up a system here. So because angle B and angle C are congruent, congruent means equals. So 10x is going to equal 12y plus 16. Because the two sides are congruent, congruent means equals. So that means my other equation is 2x plus 2 has to equal 5y. So here's my system. I'm going to rearrange this so I can set up the problem to do elimination. So if I want to do elimination, then that means I'm going to subtract the 12y so I can get the x's and the y to the same side. That means that over here, I'm going to subtract the 5y. But then that means that the 2 has to get moved to the other side, so I'm actually going to subtract that as well. So if I then start figuring out all of this on the top equation, now I'm going to have 10x minus 12y, and this is going to equal 16. And then in the bottom equation, we're going to have 2x minus 5y, and that's going to equal negative 2. To do elimination, I want to have one of the variables disappear when I add them together. Right now, if I add the x's, it's not going to disappear. If I add the y's, it's not going to disappear. If I look at the smaller numbers, they both happen to be on the bottom. 2x is smaller than 10x. Negative 5y is smaller than negative 12y. But the easiest one to manipulate would be the x's, because I can very easily turn 2 into a negative 10. So I'm going to turn that 2 into a negative 10 by multiplying the entire bottom equation by negative 5. So I have to make sure that I distribute that negative 5. So once again, the top equation, that didn't change. So I'm just going to write that one more time. The bottom equation now, when I multiply by negative 5, is going to give me negative 10x, positive 25y, and that equals positive 10. So now that I've got opposites with my x's, I'm going to then eliminate the x's. And so then I'm going to add them up. So negative 12 plus 25 is going to give me a 13y. And then 16 plus 10 is going to give me 26. So when I divide both sides by 13, I just found out that y is 2. So there's one of my answers. Now I need to solve for x. So there's a lot of different equations here. You can honestly go back to one of your two original equations or one of the equations when you manipulated and got the x's and the y's to the same side. I think what I'm going to do is I'm going to go back to the original top equation where it says 10x equals 12y plus 16. So I want to solve for x. I'm going to substitute the 2 in for the y. So we'll have 10x now equals 12 times 2 is 24. I'm going to add 16 onto that now. So that's going to give me 40. And so then I'm going to divide both sides by 10. And I get a value of x to be 4. So there is x and y. Okay, so that's us applying theorems relating angle measures and side lengths of triangles.